to the very last lesson of the measurement unit. We have finally made it after 12 lessons. It's been a while, but we've gotten there. So just as a bit of a look forward, today is the final lesson. Tomorrow, Friday, we will be doing a review day and working on some of the cheat sheet in order to get ready for our unit test on Monday. I'm sorry I'm not there with you today. I have finished marking the test, and you can see I've put the scores into PowerSchool. I will be able to return those tests for you to look at on Friday so that you can do some review and look over it for the weekend and on Friday, and we can work on fixing some things up before we do the test on Monday. But let's jump into this final lesson and get things going. So the main thing we're working on today is order of operations, and we're going to practice that skill by changing temperature or converting temperature between Celsius and Fahrenheit. This actually is quite nice to do because just yesterday we did the 4-4s activity, and it had a lot to do with operations. So just as a reminder, what are the operations that we're mainly looking at? Add, subtract, multiply, and divide. Now, order of operations is something we've seen before, and it kind of begs this question out the gates here. What am I supposed to do if I'm asking you to solve 4 plus 2 times 5? And really, there's two ways that you could look at it. You could say 4 plus 2 is 6, and then you could multiply by 5 after and get 30. Or someone else might say 2 times 5 is 10, and 4 plus 10 is 14. But which one is correct? Well, that is what we're going to talk about. In math, here we're saying we can't have this kind of flexibility. We can't have uncertainty. We need to be absolutely concrete that if I'm doing this math and everyone in the room is doing this math, we're going to get the same answer. And that is where this exciting idea, order of operations, comes in. So we've kind of determined which operation are you supposed to do first, and then what is the sequence of operations that you're supposed to do in order. And it works like this. BEDMAS is the acronym, which stands for brackets. Let's do it like this. Brackets. Exponents. Division. Multiplication. Addition. And subtraction. So, what does this look like? If you see brackets in your expression, you are going to do, I'm going to sort of say, do the operations inside first. And then if you see exponents anywhere, which is something like if you have to do a square or square root, that is what you do next. And then once you get down to division and multiplication, it actually isn't a big deal which of these you do first, but we might as well go from left to right. So we'll say in either order. Left to right. The same goes for addition and subtraction. So the order here isn't really a big deal, but we'll go from left to right. Okay, so let's just practice this skill a couple times before we talk about converting temperatures. In this first problem, I noticed brackets 4 plus 6, which is the operation that I'm going to complete first. So there's a 4 plus 6, and I know addition is way down the list of order of operations, but because the 4 plus 6 is inside of the brackets, I have to complete that operation first, which tells me is 10. Now, just as a note, if we aren't sure, I'm seeing 3 beside 10, the 10 in brackets. This is multiplication. So if you have a number that's next to bracket, you multiply. So when I look at my order of operations, I've completed the operations inside the brackets. There are no exponents, so I'm down to the division multiplication, which means that is the next operation I see. 3 times 10, which will give me 30. And finally, we'll add by 2 to get my answer 32. Okay. Over here, we see brackets again, which means I'm going to do the operations inside of the brackets very first. 5 minus 32 is negative 27. And when I look at what I have left now, 5 divided by 9 multiplied by negative 27. I'm actually in the division and multiplication phase. I think it's best if we write this out, seeing the operations a little more clearly first. So 5 division by 9 and then multiplied by negative 27. And this is now something that we could just type exactly into our calculator, and we'll see what we get. Comes out to be 15, negative 15. All right. Now we have order operations refreshed in our memory. We'll start to apply it to temperature. But before that, we can just do a bit of a debrief on temperature and how that works. How hot or cold something is. The imperial system, which is, again, in US, they use Fahrenheit. So that's probably not something that you're very familiar with. I'm not terribly familiar with Fahrenheit because we live in Canada. We use Celsius. Not trying to throw shade to one system or another. They actually both have benefits, and I'll kind of highlight them right now. Celsius was really designed to be dependent on, well, not dependent on water, but it was based on when water freezes and boils. So water freezes at 0 degrees Celsius, and it boils at 100 degrees Celsius. And that's the reason we have 0 and 100. It's just a kind of 100-point scale between freezing and boiling. The Fahrenheit temperatures, again, now they're a little bit more, I don't want to say arbitrary, but they're not as like clean between 0 and 100. Water freezes at 32 degrees Fahrenheit, and then it boils at 212. Some of the benefits, I guess, to both are Celsius is really good for science. Just because it's nice having 100 values between freezing and boiling, whereas Fahrenheit actually, when you get used to it, is kind of more relatable for human being temperatures and living ranges. There's a lot more numbers between 32 and 212. So, you know, if you're setting your house temperature, setting a temperature in your house like 68, 69, 70, you actually have a little bit more control over how warm or cold you want your house to be, because you have like more stages of temperature. Whereas if you change your temperature in your house from 19 to 20, that might be like 2 or 3 degrees in the Fahrenheit system. But you can't, I mean, on a thermostat, you can kind of change it. You can go 19.5 or 20, 20.5. So there's a little bit of control in the Celsius, but Fahrenheit, you kind of have more numbers to play around with. So I'll just say for a note here, it's good for humans. I don't know. That seems fine to me. Now, these are not things that you have to memorize. They're on the formula sheet. This one on the left, this is if you want Celsius. And the one on the right, you're going to use if you want Fahrenheit. Definitely spelled that wrong. So, there's not too many steps to practicing these questions, but this is sort of what it'll look like. 3 steps in total. First is choose your formula. Second step, substitute. 3 operations. We'll read the problem and then we'll choose which formula we want from there. But to be quite honest, when you just take a quick glance, I can already see that I've been given Fahrenheit, and it says what will the temperature be in Celsius. So without reading the problem, we kind of know what we're going to do, but just at a quick glance, Jennifer and Richard are concerned because their daughter Jessica has a temperature of 102 degrees Fahrenheit. So they take her to a medical clinic. The nurse takes her temperature on the centigrade scale. What would the temperature be in degrees Celsius? So we already know now. What will it be in Celsius? I look up here, and we're going to choose that one on the left. So we write that down. Celsius equals and then I substitute my value, 102 degrees Fahrenheit. (102 minus 32 is 70. And we get 5 divided by 9 multiplied by 70. That's something that you'll just type into your calculator now. And it comes out to be 38.9 degrees Celsius. Rounding, if it doesn't state how many decimals, then just keep one place after the decimal, 38.9 degrees Celsius. Just a fun fact, 38.9, that is outside of the normal temperature range. If I'm remembering correctly, 36.5 is typically what a human temperature is. I should know that because I have to check my daughter's temperature all the time, and I think it is 36.5. So there you go. If you're like 37.5, I think that's starting to be when you get a fever, and anything above that. So 38.9 is in the fever territory. You are not feeling super great. Probably should take some Tylenol or Advil. All right, so let's try this out for another question. Mandy supervises a road construction crew. Gonna have to change the mixture if the temperature is too cold. We kind of skip all that detail. 21 degrees Celsius. What is the temperature in degrees Fahrenheit? So choose the formula. The one on the right. Fahrenheit is 9/5. C plus 32. I'll substitute 21. It's also maybe good to note, anytime you do this substitution, it's good to place the number in brackets, just so that it makes it maybe a little bit more clear that the 9 divided 5 is being multiplied by the 21. So good habit to get yourself into. And now we're going to take a look at our operations. I like to write it out with the division symbol and the multiplication symbol. When I look at my order of operations, division and multiplication come first. 9 divided 5 times 21 is something I can place in my calculator first. And it's 37.8 plus 32. 69.8 degrees Fahrenheit. All right, so that's all there is to it. We did a refresher on order of operations, bed mass, and then we used our knowledge of bed mass to convert between Celsius and Fahrenheit. So I'll have you guys move on now and practice these questions, the on my own questions. And if you happen to get through all of the ones in the practice in the lesson today, then I encourage you to go back and start your review to get ready for Monday. So go through, complete any questions that you might not have done in any portion of the book, and or start creating your cheat sheet, or maybe target some of the ones, the lessons that were a little bit trickier. I'll definitely be spending a little bit of time on converting in the metric system for square units and cube units, but that's something that we can worry about together on Friday. So if you have any questions, let me know, and good luck in your studies, and I'll see you guys all tomorrow. Good luck.